Today, it's day 2. So the topics is day 2 focused under the neural network. My part is the very basic of the neural network. So how to understand the structure of the neural network from the mathematical side and the implementation. So probably the second part, so Kento-san, so he will teach you the framework, the very advanced one neural network, deep neural network environment on the Fugaku system. Also, my part is a very beginning, very beginner. So if you already learn the neural network and the artificial intelligence that currently is running on this many supercomputer or your laptop computer, so it is very easy. So please listen to my lecture. So so easy. Okay. So, okay, I skipped this introduction to my assistant. So I couldn't see this Tero-san, but so this so presentation material and a sample code. So these are written by my staff, my team staff. Dr. Takeshi Terao, he wrote a code and so the most of the material in this slide. So I really appreciate him. So, okay, so my introduction and so, this is my name. So this is a Japanese character. Toshiyuki Imamura. So now I'm reading the team or large-scale numerical technology research team, and so my expertise on high-performance computing and the numerical linear algebra. So especially I'm developing this eigenvalue solver. So usually, so I don't touch the deep neural network, but last year, so I was asked to teach the very beginning of this topic. So I made a very sample code. Though it's a very close related to the numerical linear algebra. So yeah, that is a very nice topic to me, and also the beginner for the neural network. So if you want to access or interest in this, my team's activities, so please visit this URL. Okay, first of my lecture and talk and the hands-on. So please make sure so your PC is so it's going to access the Fugaku system. So please make sure that your PC status is already updated the newly operating system version and the antivirus software. And also during the hands-on, so you should edit several codes, source code. So Fugaku system is a very conventional supercomputer. So we don't provide you or visualize the editing system. So BI, Nano, Emacs, these very classical editor are provided you. So yeah, you should used to be this the classical style editing and compiling. Yeah, I'm sorry. So we should prepare more modernized the programming environment. But so, yeah, we cannot cover most of the people. That is the style and so our CCS. Okay, if you want, if you have also any questions, so please mail me. So email address, this is listed here. And so I think you can download this slide from the RIKEN box. It's open to the all participants. But also when you edit the file, please carefully consider the copy and paste line, because sometimes PDF files it converts the specific character, for example, the minus. So it is sometimes encoded to the other characters. So yeah, typical case is the n dash. So if you have any trouble, the copy and the paste, so it might be happening. Okay, so pretty carefully check several times the copy when you copy the from the PDF and PowerPoint file. And so today I checked the cloudness of the Fugaku system. So just 1 hour ago, Fugaku was very cloudy, and so the one login node was crashed. So yeah, so I try to switch to access the Fugaku to the Google Collaborator. So yeah, of course, you can run the Python script on the Fugaku, the login node. But if you when we visualize this all the results on your PC or laptop on your site, Google Collaborator, so that is a nice environment to share the source code and the results interactively. So if you have, if you already have a Google account, so it's okay. But if you don't have any Google account, so please create, to access this URL. So if you can access the Google Drive yourself or the Google Collaborator, so yeah, you don't have to care. That's it. Okay. I think we have enough time during the hands-on. So yeah, please ask me this any preparation has not yet done. If you have some difficulty to access the Fugaku, but today, so I already prepared the option to use a Google Collaborator. So don't hesitate to ask me. Yeah. So okay, my talk today is. I'm sorry, this should be there. Okay, my talk today is the very beginning of the deep neural network. So the essential or the principal question to us to start the study or the practice of the practical study of the neural network is very very essential of the human interesting. So I also have the question to you or any participants. So what do you imagine the AI or deep machine learning or neural network? Because as I told you, so usually I'm working for I'm developing the numerical algorithm or the numerical parallel the software on the Fugaku. So not a AI expert. So I also have a question, but I don't have any so what to say? So answer to the sort of beginner. So yeah, I think it's a good experiment to learn the AI or some answer the why the human should or the human going to develop the sort of AI. So yeah, that is a good question, and so this is a very good experience to learn from the non-AI person. Yeah, today this slide is this lecture is done very often. So I think it's the first time. I use a textbook, so it's written. I think it's a very famous, not already not share book. Budumar, he wrote this book. So its title is "The Fundamental Deep Learning: Designing the Next Generation Machine Intelligence Algorithms." So you can access the website, and you can also purchase this textbook from the bookstore. So at the beginning, I should mention the sort of what is AI and the sort of what is the target. We can summarize the artificial intelligence. So briefly, we can say that AI, artificial intelligence, is a sort of the intelligent machine. So here is a question that can we emulate the human brain on your or our computer systems? So this illustration, yeah. So brain, human brain, and the PC. So these are so equivalent. The question is that we can emulate or we can establish this relation. The brain is inherently or makes us the intelligence. So that is a dream or building or the intelligence machine with the brain, like our the brain. So that is sort of our ultimate dream. But we have to develop radically different programming of computers using techniques largely developed over the past decade. Because 20 years or 30 years ago, we don't have a sort of similar system. So currently, so we are saying the sort of deep neural network or deep intelligence machine. So the system and the sort of idea, this is completely different. We have to think about the traditional way. Why that we couldn't emulate the sort of human brain on the sort of the previous or the past study, because there are a very big limit. The limit of the traditional way is hidden in the programming. So traditional computer program can, of course, it does the trick for the determining or non-variable issue. So here is an example. So it's like the character. So how recognizes the messy 0? So I roll a 0, but so you can someone see this. It is sort of a character 6, digit 6. So how do we write a program? So this has the probability of the 6 or 0. So you can document the rule one after another. So for example, the points where we start this character, and the stroke, angles, and the lines radius, or something like this, when you're drawing character. So these rules are listed up. So these are the very classical style. So here here's the very famous the database MNIST handwritten letter test. So there are so many pictures, so the handwritten letter. So the goals to develop the no, it's not a arithmetical, but also as a milestone, it is neural network or the artificial intelligence can recognize the handwritten character. So this is a very good example. So 0 or 6. So okay, so presented the artificial intelligence system so rely on the very different approaches. So not only so listed up the rule-based database. One principle is sort of human. So we learn a lot of things at the school. We took more than 20 years from the junior school to the advanced graduate school. So we learned how to multiply the numbers, the solve equation, and the derivative, and further. So it starts from the very principal calculus to the sort of very the abstract to the mathematics. The things we find so the most natural are learned by example, not by the formula. When we read the sort of textbook, but so we should do some exercise and the practice. This is a sort of many examples. The deep learning, it is equivalent to the subset of the more general field of artificial intelligence, machine learning. So here, one equation. It is just a formula of the linear perceptron. This function h, so input is x and theta. It's categorized as the input value x to the sort of positive or negative value, so -1 or +1, according to the this relationship. By this picture, so h, so linear perceptron function, it's going to try to divide the parameter fields x1 and x2 to the sort of two regions, negative field, negative part, and the positive parts. The idea to construct the neural network is very essential to current deep neural current artificial intelligence. But the essential part is this property of the sort of linear perceptron. So just we categorize this parameter field or parameter space to regions, negative or positive. Okay, so as I told you, a neural network, so many times. So neuron, so it is the fundamental unit of the human brain. So this is called a neuron. This is a very tiny piece of the brain. It's the size of the grain of the rice. But in the human brain, it contains over 10,000 neurons, each of which forms an average of 6,000 connections. Yeah, these connections, it's more than 6,000 other neurons. So it is a massive biological network. So it enables us to exercise or the experience the world around. Oh, yeah. So it's due to information processing. We touch anything. So human brain try to understand the and also brain receives a signal from eye. So the brain is going to make some vision. And also that we hear some voice or some noise. So we try to understand what's noise or what's this who is now talking about. Yes, it's a very, very complex the information processing. But so on constructing the sort of very similar machine or the similar mechanics, we have to simplify the sort of the system. So yeah, as I presented the previous slide, so the linear perceptron, so it is a sort of essential. So and also the neuron, so it is sort of networked on the in the sort of human brain. So we try to emulate we try to construct the mimic of the sort of network by so it's embedded the neural function. So linear perceptron here. So of course, input is a very many channel. So input is, so we can interpret many sensor data as a sort of vector. So x1 to xn, so much variable vector. But so the perceptron, this has to input the scale. So we try to project the sort of multi variable to the single scalar. So this translation, so compute the inner product of the weighted vector W and the input vector X plus offset B. So this is a calculate to the sort of Z. The variable Z is input to the sort of function, neural function F. So we can get the sort of result Y. Y is either -1 or +1. It depends according to the sort of input value X. So yeah, we can summarize the sort of what we are going to this neural network is just similar to this picture. So here is so there one photo. It's shot the cat. I believe this is a cat, but also other one. Someone said that this is not cats, so it might be a puma or a baby lion. We want to try to identify this. So this might be a high possibility or the probability to the cat. So the neural network. So this mechanism or this system, let's try to identify the probability. So this auto target is what is the animal, or what's animal is high probability to this photo. Okay, so as I told you in the previous slide, so here is input data is the vector X, and there is a big network. So in last slide, it's just only I explained the sort of single neural function, but in the human brain, so more than 6,000 or 10,000 neurons are connected. So very complicated networks are here. So we can write a capital F X. So input the data vector x to the capital F, and then we get the result of y. So this can decode it because this is a digital number. So we can interpret this vector in output vector y as a sort of list of the sort of probability to the sort of target or the possible for the animal. So this is illustration shows sort of a very good example. So the final goal to construct the neural network or the deep neural network is to find out the very complicated complex function capital F or its parameter. So capital F. So its network contains so many of a lot of huge number of the parameter, unknown parameter. So find or the fix, define, determine these unknowns. So or approximate them. So this is a sort of final goal, or this is a sort of purpose to construct the sort of neural network or just study. So, okay, this is optional one. So, yeah, so previous slides, yes. This is a sort of very one example to use the neuron function. So linear perceptron is a sort of one example. It's just categorized the input vector to minus or plus 1. But here are many possible the function which categorize the sort of input value, input vector to the plus minus. So sigmoid functions like this, and the tangent, hyperbolic tangent, and the ReLU, and the softmax. So these are utilized often in the deep neural network framework. I think a sigmoid function is very easy to understand, or mathematically or analytically to calculate its derivative or the more complicated function or representation. But sometimes we use a softmax and a ReLU. I think some ReLU, this is good. It uses. It is often used in the sort of neural net framework because implementation is very easy, and so it is matched to the very much to the GPU. Yeah, you can see this just only the linear function. Okay, so. Okay, so the purpose to run this neural network is to structure a very complicated the function capital F. But the capital F, function F, so it contains a lot of the hidden unknown parameters. These are the so I don't know how many the parameters are determined. In most cases, more than 100 or more than 1,000. Yeah. So how to define this function? So this is equivalent to the define the function F, neural function. So now, at first, we suppose we have a large number set of training example. We have as input and output set, and also we can calculate the return value or scalar value or the vector of the neural network in the the capital inside of the capital F. So here we can define the error function between input data and I'm sorry. So it is a training data, and so it's corresponding output value of the function f. If the L function capital E is of course you can see this is a sort of square, sum of the square. So the minimal value is 0. So if E is 0, we can completely or the perfectly approximate sort of function, unknown function f. So we try to minimize sort of this L term. So there are sort of many approaches from the applied math. So I think you can see you have learned gradient descent method or the steep descent method for the sort of unknown function. Because the L function, L cost function is written by the sort of this formula relation. Gradient descent. Its derivative is easily to calculate. So we try to use this approach. If we plot the contour map of this L function, so we can draw this kind of contour. So we try to find this from this point to search the sort of gradient direction, and another point, another point, another points, and so finally, so we get all the optimal this points. It minimizes the sort of error cost. For the to calculate the to proceed as the gradient descent method, we have to calculate the gradient of the L function. If we get this part, we can automatically or systematically update any unknown variables. So this is the very principal part. So in a square, so we can put the unknown parameters. Unknown parameters can update multiply the certain parameter weighted parameter, and so the derivative gradient of the sort of L function. So question is how to change the weight parameter. So because the weight parameter is an unknown parameter that's contained, or it's one part of the sort of neural function, capital F. Steep descent method is the approach. Now we are going to do that. Okay, so first we have to calculate the partial derivative of the L function with respect to the H weight term. So if you want to update the parameter WK, we need a sort of derivative of the L function E by or with respect to the sort of WK. Yeah, but by using the chain rule of the sort of partial derivative, so we can rewrite the this term by like this. Now relation to intermediate variable z and input data vector x is so like this. It's a linear combination. So and also we have neuron function f. So f is now sigmoid in neuron. So it's written by this formula. Following the sort of this relation, so we can compute the variable first partial variable, no, first partial derivative, by this formula. So we can update after calculating this value to the weight. We can update this weight by weight factors every step. So in the last line, by using this obtained rules of for the weights unknown variables, so we can modify all unknown terms step by step. After we update the old unknown variable, we also again evaluate these values again. So it is an iteration until the convergence. Okay, so so the formulation between okay, so at first we only have the definition of the Euler cost function. So in that case, we only calculate the output. So the partial derivative with respect to the output vector y. But to update all the intermediate weight factor or weight value w, so we have to calculate the round a, round z, or round e, round w's. But the definition is very simple. But we can follow this relation. So because so intermediate variables and the neuron functions are defined by another rule. Wij is so like this. So last previous pages, we know only the relation, the output and the input test data at the beginning. But also there are the method of the calculating the error term in the middle layer. So the network has a layer. So at the middle layer, so we can successfully form the error in the final output layer, but it is backward from the output to the input to the that is the initial layer. So that is a very significant property to update the unknown factor. So that is a code, so the back propagation, because our update to the unknown factor is propagate from the output to the initial input data. This is the backward the calculation. When we calculate the error term, we have to successfully evaluate the neuron function inside the network. This is calculated from the initial to the output. This is a forward. Yes, that is a contrary, very opposites the idea to calculate. That was the backward, so we say. Okay, so this illustration, it's going to present the summary of the here just only one layer to calculate the neuron. Here is input data X, and so we translate the march data input X to the Z, and we calculate the output. So here is output is Z here. and it is also input to the second neural network. And so finally we get the output Y. In the case, the evaluation, the error function, it is going from to start from the reference left side X to intermediate values here A0, Z, A1, and then finally so we get a Y. But so if we update the unknown factor here, unknown factor is W and the B. It is calculated by the backward. So we calculate the partial derivative ln E ln GI and the ln E ln XY. Yeah, so this over. So we calculate this one and this another one. But the formulation is simplified by the matrix multiplication and the matrix element-wise multiplication. Yes, as you can see, the long gradient Z gradient. I'm sorry, how to say? Partial derivative E by Z. It is written by the multiplied of the matrix W1 and vector. So there's a small factor, perturbation factor of the delta Y. But the delta Y is calculated by the first derivative of the neuron function F1, and it's other model product element-wise multiplication. So difference the output and the test training data. And then so we can calculate another one of factors. So ln B and ln XY. So this is also we can simplify this calculation by this formula. So matrix vector multiplication and the matrix element-wise multiplication. Yeah, it also summarizes the successful process to obtain the gradient of E, and so we update the unknown factor. Yes, most of the odds also written in the matrix vector, matrix. That's why we have to learn the linear algebra in the neural network or artificial intelligence. Okay, so finally, this is a very schematic view to the there is a simple case in the matrix vector form. Yeah. Okay, I skip this one. Okay, so now, okay, 15 minutes. Okay, so now, lecture is almost, so I tried, I think so it's a good, good time to start the experiments, numerical experiments, the very simple or the very toy neural network program. So example is, as I told you, so there is a very famous MNIST database, like, so they want handwritten digits characters. So we are trying to learn these characters, and we try to identify the certain specific picture, which character, so which digits are also displayed. Okay, so okay, so I will try to skip. So okay, so I think so you already downloaded so this PowerPoint or no, it's not I provided you as a PDF file. So please jump to this Google Drive page. I think we can. Yeah, if you successfully jump to the Google Drive. So it's automatically forward to the Google Collaborator page. So in the Drive, so here is some example of the Google neural network program. So this is shared by all the participants today. So please copy this Python files. So click the file tab and copy to where is save? Yeah, save to your Google Drive. So you can after you copy this Python scripts, you can edit by yourself. Okay, so run this Python script. Just only push this icon, play icon. Yeah, scroll down. So here is Python script and another Python script. And so this is the final one. Oops. Oops. Well, but there's this one error. What's happening? Let's download this. Okay. Load. Okay, so thank you, Sato-san. In the chat window, there is a URL, so you can click here. So yeah, so you can jump to the collaborator page. Click. Okay. Click. Okay. The last one. Okay. So if you successfully load all the file from the outside the Google, we should get the database from the MNIST site. And if you successfully run the Python script, so you will get such kind of result. The first part is a learning process. It shows us accuracy and the training. It is equivalent to the cost error function values. No, it's not an error function. No. It is accuracy to the one. So it shows that the difference. It's not a difference. It is a ratio to the correct data. Yeah, I'm sorry. It's not error functions. If we indicate there's an error, so 0 is better. But in the case 1 is better. So this neural networks it iterates 10,000 iteration, and to finish there's a learning process. And so randomly pick up the 6 picture from the database. So it try to identify which these characters, which digits these characters are. So you can see this is 93405. Okay, this is okay. So this example is very good. But also, this is these are samples of randomly, so you might get also very bad results. Okay. Now I'm running a second time. Okay. Okay. Oh, it's also a good result. Okay, so sometimes this the neural network, the program, Python script fails to identify the character. So yeah, I couldn't learn the wrong case, but you might get so please run by yourself several times. Okay, this is the results. So when this neural network fails to identify or to categorize the key characters. In the case of the human, so we accepted these characters as a 0, but so this human, neural network scripts, it's accept this character by 7. I think this looks like the 7, but for me it's 0. Yeah, this might happen to the handwritten code. So another case is the fashion MNIST. So it's quite more advanced. I don't know. The difficulty is much higher than the handwritten characters. So if you modify if you modify the top parts, so load MNIST Python scripts. This script in the script, the neural network script codes try to load the database file. So if you comment out these lines, and no, sorry. So it's erase the comments, triple quotation, and also commented out the old one database loading port. So you can run this fashion MNIST case. And the more advanced case is Japanese kuzushiji hentai hiragana. Because our Japanese characters, hiragana, it comes from originally Japanese Chinese character. So at the very early, for example, 10,000 or 15 or 16,000, 15 or 1600 years ago, hiragana character, these are so like this, almost similar to the original Chinese character. It's just a broken style. So yeah, so KMNIST Kuzushiji database site, they provide us this handwritten hentai Kuzushiji database. So we also apply the neural networks Python script to this character to identify which characters are there. So so for us, even though for the Japanese people, so it's quite difficult to read these one, but there are some neural neural network Python script. So it's sometimes successfully, but sometimes fail. This case, this character, it's written O because the answer should be 9. So O, this character. But neural network scripts, it's identified this character as number 3. You see that, no, na, number 4, 3 or 4, 2 or na. Yeah, so that's that is a failing case. Okay, so please enjoy the neural network. So very so toy even though it's a toy program, so you can enjoy the very toy program. Even though the toy program it can detect correctly this picture. Okay, so here is some notation. If you try to run this Python script on your PC or the Fugaku front end, prepare some Python packages available on your system, NumPy and the matplotlib and the pillar. They are indispensable. So on the Fugaku front end, so you have to run or prepare these package by user. And the pillars package, so these 1, 2, 3, these are sort of essential. Otherwise, you will fail this implementation installation. And the NumPy matplotlib, so they are easy. Just only type this. And I copy the file. So I prepare the Python script on the Fugaku. But I think this source code is accessible to provide the user belonging to this group. So if you can access the RIKEN box, I also put the same table on the box. Well, Kento-san, could you put the box URL to the box on the chat box, chat window? Yeah. And so just only type the Python and then py, so it runs the MNIST handwritten characters example. And as I told you, so if you edit the input data script, so you can apply the this Python script to the MNIST fashion and Kuzushiji character. Okay, so almost all my lectures are done. Thank you very much. If you need a advanced or more practical AI skill and knowledge to the HPC framework on the Fugaku, the next session by Dr. Fuhato. So that will help your future works. Thank you very much. Lots of time. I think my lecture continues by the 6:20 in Japanese time. So now we still have more than 15 minutes. So please enjoy the Python script. Yes, I try to learn hentai Gana. Okay, now I'm accessing the Fugaku, and so I'm enabled to access the whole port 4, the X protocol to my local PC. So we can I can run the Python script on the front end of the Fugaku Python .py. Oops. No, I'm sorry. That was wrong access. Oh. Okay, so it's now running this Python script on the Fugaku. It's not a Fugaku backend, just a front end. Okay, so I think the front end is very busy for so many user. So today it's very crowded. So Google collaborators. This is the first. Okay, so I don't see there's any question in the chat box. So if you have any question, please post on the chat window. Okay, so now it's trying to send the window to my laptop. Oh, yeah, not a window display. Yeah. So last case, case 6. So the script fails to identify the character. Yeah, there should be 3, but let's try to suggest this character is 9798. No, it might be 7, but it's wrong answer. But the other 3, no, other 5, and some example is correct. Yeah, thank you for the question. So because we learned the Python script on the Fugaku front end, it's shared with the many users. Now, I don't know how many users are accessing. I can see, you can see, yeah, these people are using the sharing the sort of front end. So yeah, it's very easy. Yeah, that's why the Google Cloud Run that showed a sort of very fast results. Thank you for your question. My session あと10 minutes か。ページはもう一個やりますか。Okay, so I try to run the 検体崩し字 example. This is not broadened. Okay, so comment out this original reader or handwritten characters case. And release the comment triple quote session. Yeah. I think we need to wait almost 1 minute or something. Oh, no. Yeah, maybe 1 minute or more. Okay, so I think if you have the Python environment running environment available on your local PC, so you can download the code DNS code TGZ. So you also run on your PC. So I think it is much comfortable. You don't have to wait the CPU time. Okay. Oh, it's just almost 1 minute. Okay, that is the result. Oh, but I should need this. Yeah. I'm sorry. Yeah. No. Okay. You see that's a 6 sample example, but one case it fails. The other 5 are successful. Yeah. So if you want to modify, or if you want to utilize this neural network code, so it's written in the sort of the Python, so it's quite easy to apply to your study. So neural network, so learning process and is also, yeah. So here, this main loop is the learning process. And if you want to modify the neural networks, so yeah, now just two-layer networks are constructed. So yeah, this kind of here is, yes, two-layer network. So you can modify, or you can update this script. Yeah, triple-layer merge deeply layered network. The more complex or the complicated one is easy to build on your system. But building also so deep, for example, more than 100 layers of network is quite difficult to write a code. So the framework is necessary to further the practical study. So next session by the Sato-san. So that is very so helpful to there's a practical study. Okay, Sato-san, I think that's almost my lecture and session.
Okay, thank you very much. And yeah, so we still have some time, but let's take a break until the next lectures. It will start from 6:40 in JST, and what the time in France? It's 10:40. We will start the next lecture from 10:40. And so please take about 20 minutes break, and we will resume in 20 minutes. Yeah, thank you, Imamura sensei.
Yeah, thank you very much.